All right, this is the Algebra 1 Unit 4 Lesson 1 video. This is a bit of a review. We covered this material in Unit 2 of Algebra 1, and so we're kind of coming back around to it so that you can kind of understand a little bit more deeply. So the first thing I'm going to say is I'm going to post in this video link or in this video description a link to that other video, and it will be included in the playlist for this unit. You need to go watch that video. It's going to describe to you the basics about what is a function and what is how different ways a function can be represented. But in the lesson here on this video, I'm going to go more deeply into how we determine whether or not functions are whether or not a relation is a function. So the first thing is there's a ton of vocabulary here in question number 1. You need to use the vocabulary words at the top of the screen to do that. And then there's just a bunch of questions where they ask, determine if this represents a function. So that's like questions number 2 through 8. So I'm going to kind of remind you one major concept of whether or not something is a function. So remember, the basic difference between a relation and a function versus a function is that in a relation, it's just any set of ordered pairs. It's just anything. It doesn't matter. It's like 2, 3, and 4, 9, and 1, 2, whatever. It doesn't matter. Any set of ordered pairs. And those can have repeating answers. Notice how there's like multiple that have the value of 2 as the first value. Now that is going to come back into play here, but a function means this. It's ordered pairs where each domain value, or x value, has only one range value. So in other words, the domain, the x values of your function cannot repeat. Okay, so the simplest way to say this is that you need to know, again, is there any kind of repeating happening in terms of the x value? So just to remind you, in a function, for functions, what a function really does is it uses some rule. Okay, we're going to call this machine a function. We'll put it as an fx. That's some kind of function. And you're going to have, it's like a machine. And you're going to put something in the machine, and the thing you put in the machine is the domain. You put domains in there. You put x's in there. And when you put those x's in there, on the other end of that function, out pops a y, or a range value. But we want to know that when I plug in a certain domain, I want to predict what the range is going to be. In other words, I don't want to put, I don't want to go put 12 in this function and then get a 6. And then the next time I go to plug a number in the function, I plug another 12 in there, and I get 9. And then I go again, and I plug in 12 again, and I get 14. So that doesn't help. That's not what a function does. A function has a predictability to it. So this would be an example of a relation. 12 goes in, it plugs out a 6. Then the next time it is a 9, and the next time it puts a 14. But for it to be a function, it has to be one-to-one. In other words, there has to be a predictability to the answers when it comes to the range. Each domain has just one range. Now, it's okay if the range repeats, because different domain values can come out with the same answer. But you can't have a domain go in and then spit out multiple different answers. Okay, so when we say that we're talking about a function, it has to be non-repeating on the domain. So what does that mean on your actual lesson? Well, in your lesson, let me hop over there. they're going to ask you to do some things. They're going to ask you to determine if the ordered pairs represent a function. Well, I'll just tell you right now, all you need to be looking at is the x values or the domain values. If any of those were repeats, you would say no. Since there are no repeats, 1, 4, 5, 6, then we're going to say yes, that is a function. But if there are any repeats on the x, the answer is no. Same thing down here. If any of the domain values point to multiple range values, meaning there are two arrows coming from a domain to multiple range values, the answer is no. So you can't have any domains going to multiple range answers. Same thing on the table. If you have the domain repeating, going to multiple ranges, so if the domain has two of the same number and the answer on the range is different for those two numbers, then for that number, then you have no. As long as it's 1 to 1, you'll have a yes. Okay, then they're going to ask us about discrete and continuous functions. Just go over that really briefly. So when you talk about discrete versus continuous functions, discrete versus continuous functions. Discrete functions versus continuous functions. So a discrete function means that it would be graphed like the following. You'd have individual values separated. It's like each one of these is a value in that function, whereas in a continuous function, it is continuous. There's kind of like the line just continues. There's no separation between the values. That's all you need to know. It can be any shape, but as long as there is just continual values, no gaps in between, that is a continuous function. So that will help you with 9 and 10. Then they ask you about the vertical line test. The vertical line test is very simple. The vertical line test says that when you're looking at the graph of a function, so I'm going to draw a few different functions here. So I have these different functions here. And let's say I have one that's like this. So I have one that's like this, and I have one that's like this. No, that doesn't work. Let me do a different one. Yeah, like this. Okay, and they say here, are each of these functions? Well, the vertical line test says that if I can draw a vertical line that touches the graph more than once, then that is not a function. So this one, notice all these vertical lines, they touch only once. So yes, that is a function. Same thing here. I have vertical lines, they only touch the graph once. Yes. Whereas here, this crosses the graph 3 times. That is no. That is not a function. So that's what the vertical line test has you do. If you can draw a vertical line that crosses the graph more than once, then it is not a function. So that gets you through number 13. All right, number 14. This is going to introduce kind of a word problem idea. So they want to know if this is continuous or discrete data. So the question is, are these individual values that are not joined together in between? In other words, can you sell half of a t-shirt or 3/4 of a t-shirt? If you can, then that's a continuous data. Okay, if you can only sell whole t-shirts, 5, 9, 13, maybe 12, 14. If you can only sell whole t-shirts, then that is discrete data. So that should be pretty obvious from what I just told you. I kind of gave you the answer. So just think about this situation. Is this individual values, or is it a continuous set of numbers? Whereas you can sell parts of t-shirts in between each numbered shirt, 5, 6, 7, 8, 9, so on. Can you sell half a shirt, 3/4 of a shirt? You guys will be able to figure that one out. Now they kind of throw this in here. I'm going to do this one for you because we don't really have a good example from the lesson on this, but this will help us kind of discuss domain and range briefly. So domain and range, remember, domain is the x values, and the range is the y values. Remember, domain means it's going the left to right, and range is going up and down. So when I say what is the domain of this function, I'm asking the question, where does it start and end on in terms of the left to right distance? So I see the graph starts here and stops here. So this is the domain. It goes from 0 to 14. And then when I look at the range goes up to 7 and it goes down to -1. So this is the domain, and this is the range. So I see the domain goes from 0 to 14, and the range goes from -1 to 7. So we try to find, I see this one 0 to 7, that's wrong, so that's not it. I also see 0 to 7 here, so that's not it. So these check out on the domain, but then on the range, -1 to 7, -1 to 7. So this, one says they both have the same values for range. So is it a function or is it not a function? Well, I can use the vertical line test to check that. And I see there are no places where the graph crosses twice. So then it is a function. All right, so that's the end of this video. Hopefully you guys are able to finish this. Please reach out to me if you have questions. That's the end of the lesson 1 video.